so we're looking at using Venn diagrams to represent sample space and solve problems. One important, in the semester exam in grade 12, about half of the kids lost a point because they didn't show the rectangle around the two circles in the center of the Venn diagram, and it was required. So make sure you don't skimp on the rectangle. So the rectangle represents the universal space on the entire sample space. So in this case, the universal set is the whole numbers between 1 to 10 were being defined. R is the number that are less, that are 5 or less, and S are the factors of 12. Have a go at copying the Venn diagram and put the little numbers in the correct holes. All right, so we need the numbers 1 to 5 that are going to go into R. Those are pretty easy. The factors of 12, we have to be careful with those. Is 1 a factor of 12? So it's going to be in both R and S. So we place it here in what we call the intersection. This is called the intersection. How about 10? Is this a factor of 12? No, it's not a factor of 12, and it's not less than 5. What about 8? No. Put this on the outside, inside the universal set, but not in either of the two defined sets. Is 4 a factor of 12? Yes. That can go here. What about 3? That needs to go in the intersection. Listen to the vocabulary music, the intersection. What about 7? Is this a factor of? No, that one's on the outside. 5? No, that's not a factor, but it is 5 or less. 6. Is a factor of 12, but it's more than 5. 9, that's going to go in the universal set, and 2 in the intersection. Let's use these to work out the probabilities of A and R. So the probability of R, well, how many elements are in set R? Set R is defined as being, so set R is these numbers, it's this space here. This is R. This is R. How many elements are in this space? 5. Out of a total? 5 out of 10. So this is a half. So factors of 12, that's this space. I like my highlighter pen this time. So the probability of S, you can see, is also going to be a half. We've got 5 out of 10 again. Okay, so a bit of vocabulary. When we describe different regions of the Venn diagram, here we see the intersection. This is where two sets overlap. That's the probability of A and B, or that's the number of elements in A and B. We have a symbol for this one. Does anyone know what the intersection looks like? Amelia? Yes. So this is A and B. So it looks like this. If you put the whole two sets together, you get what we call the union. So this is all of the elements inside A and B. We only count the elements in the intersection once. We don't count them twice. So does anyone know the symbol for this one? Somebody else, Kai?
U.
Yeah, it looks a bit like a U. And then we have the complement. So the complement of A is the region that is not in A. You see here in the last Venn diagram shaded. How does the complement look? Really? An apostrophe. Excellent. So this is not A. An interesting thing is that not A is equal to 1 minus A. Or, sorry, let me do it as probabilities better. The probability of not A is equal to 1 minus probability of A. We call this the complementary probability. Complementary probability. It's a formula we're going to use quite a bit. Guys, can you put your phone away, take your earbuds out, and maybe join the class soon? So which objects are in the intersection of A and B?
B.
So the intersection of A and B is a set. We have the elements 3 and 8. Notice the vocabulary, notice the notations. So the intersection of A and B is the set with 2 elements, that is 3 and 8. We have a notation for counting the number of elements in a set. So the number of elements in set A intersection B is 2. A little bit of notation. Which objects are in the complement of B? So we want B complement. Which ones are in B complement? 3 elements, which ones? No.
Oh, no, sorry.
Lucas? No?
7.
Troy?
I think it's up B 417. Oh, it's 3, it's 3.
You said again?
That's a 417.
417. So you said 4 and 7. So the number of elements in B complement is what? 3. Let me shade that region for a second for you. So B complement, basically go around that and then shade everything else. That's B complement. Which object is not in the union of A and B? Not in the union of A and B. Let's see how we write that. This is what causes the problems. So we want the union of A and B, A union of B, and then we want everything that's not in that. Everything that's not in the union of A and B. Which subset is this? Seven. 7. So 7 is the only element in that set.
So I have a question. How come for B, like this, the one that we did before this one, how come it's 3 and not 5 if it's all of them except for the shape one?
It's everything in the shaded one.
Oh,
Everything in the shaded one. How many elements in this set?
8.
What?
Because it's only 7.
It's only 7.
Oh, I mean, that one.
Only 7.
so
Okay, so copy these Venn diagrams and shade them according to the notations here. Copy these Venn diagrams and shade them according to the notations. Okay, so A intersection B. This is the intersection of 2 sets. This is pretty easy. And then this one at the bottom below it, A union B. That's going to be like this. Everything here. Now, this next space is the most important one. This is a hard one. This is a hard one. We often want to refer to this space. We want everything that's not in B, and we want everything that's in A, and then we need the intersection of those two. So this describes this space here where not B intersects with A. Okay.
Last one, yeah.
If you wish.
You only shade in like A as a whole, and then like the rest of it.
No, it's all of that outside except C.
This one here at the bottom, it's the inverse of this one to its left. It's the inverse of this one here to its left. So we need to shade like this.
Is it because it's in the brackets?
Yeah. It's like, that gives us the order of precedence of how to apply the operators.
Okay.
These are set operators. So this is the complement of A union B.
Sir, I have a question about the last one.
Okay.
Just really quick. For the A intersection here.
Sorry about this. Right.
10 is
Go on.
No, that's not. For the A.
Sorry, can we have quiet, please? Questions from the class are often important for other people to hear as well. Asha, can you remove the earbud out of your ear?
For the one in the top right, if it's the intersection sign, how come it's like the middle is wrong, like the intersection is wrong?
Because this refers to the, you can have an intersection of many different sets and pieces. This is the intersection of A and B. But we want the intersection of A and not B. Different sets.
So
So it's, the intersection doesn't refer to, the intersection symbol doesn't refer to this space. When applied to two different sets, it creates a new set, a new subset, and then we have to identify where in the sample space that is. But good question. Because we do often call that the intersection, but it's not. It's the intersection of A and B. We're just being lazy. Okay. In a class of 26 students, it's found that 10 study geography, 16 study history, 4 study neither geography nor history. Calculate the number of students who study both history and geography. Have a go for this for yourself. Work together with a partner. Have a look. So,
Why would you just choose 65?
how many students are there? How many students are there in the union of A and B? How many students are there in the union of A and B?
How many students?
And how can we work this out?
We make A who study geography and B who study history. Yeah, we do. Are you the 10 and A? No.
No. So the most important thing is that 4 of them study neither. 4 of them study neither. So we got 4 here. How many students are there in, sorry, should be a round bracket. How many students are there in the universal set?
26.
26. If there are 4 students here in this space, the rest are in the union of A and B.
22 students that take geography.
There aren't 26 students that take both because some of them take, sorry, there aren't 26 students in the union of A and B because some take both and you'll be counting them twice. But the universal set is 26, so that means this has to be 22. Rub that out, start again. So it's 26 here, which means that the number of students in A union B is 26 minus 4, 22. Open up the formula sheet that I've given you on the table and turn to page 5. Turn to page 5. Find the formula for combined events. Find the formula for combined events. Find the formula for combined events. Now, this formula can be rewritten to talk about the number of elements in the set. It doesn't have to be just used for the probability. So the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A intersection B. How many are in the union of both sets?
22.
22. How many are in A? How many are in A? A is, A must be geography, yeah. Let's go for it. Let me not name them. This one's A, this one's B. So we've got 10 here. And how many in geography history? 16. So how many have to be in the intersection? 4.
Where did you get B?
Is that, what is that?
I'm not like sure.
So calculate the number of students here is 4. So how many, so this space here, what do we call this space here?
Yeah, that is what I know.
A.
No.
A without B. D apostrophe.
Explain to the person next to you what we call this space here. Make sure you know how to express this accurately. About 90% of you don't.
How would you say intersection?
I agree with you.
Okay. How do we name this region? How do we name this region? Good. A intersection B complement. This is A intersection B complement. How many students are in this subset? How many are in A?
Six.
How many are in A?
10.
So how many are here?
6.
Yeah.
Good one.
Okay, explain to the person next to you what we call this set. What do we call this set? What do we call this set?
Only the yellow?
Yeah.
Oh, okay. A complement intersection B. It would be A and B with the apostrophe thing. On the B comma.
We need the words.
B.
We need the words.
A complement B.
A complement.
B.
No.
Oh, intersection. And intersection.
Intersection. Not N. It's not an A.
It's easy to think about it like that. And then B.
And then B. How many elements are in this region?
12.
4.
Shout out. Spoilers.
Others.
Spoilers. 12. Add them all up. Make sure it adds up to 26. Does it?
Yeah.
18, 22, 26. Okay, calculate the probability that a student selected at random from this class studies exactly one of these subjects. 1.
6 plus 12. That's
0.692%.
18.
70%.
9.
Let me do the register. Okay, so we need the probability that a student selected at random from this class studies exactly one of these subjects. So we want the probability of one subject only. So we need the number of elements in this green set, this yellow set, 18 over 26. We simplify, what do we get? 9 over 13.
70.
Okay.
Oh, so we don't put it as a percent? You don't want to.
No, fractions are best. Fractions are best for probability. If you have a question with multiple parts, sometimes I don't, particularly with this method, sometimes I don't simplify the denominator, especially if they all have the same denominator. It's nicer to compare them then as well.
You lose marks if you don't.
You don't lose marks. No, you don't lose marks for not simplifying your fractions. Yeah.
That's good, because I don't want to simplify.
Okay, so these are the formulas we've seen on our formula sheet. We're going to have a little look at these. So if 40% of students choose A and 25% choose B, then how many students choose A intersection B for the choice of A and B to be independent?
That was so confusing.
Read it through, think it through. Okay, so look at the wording. It says 40% of students are in A, 25% choose B. How many have to choose A and B for the choice of A to be independent of B? So here's your keyword, independent. Turn to your formula sheet. Is there one of the formulas that talks about independence? There is. Independent events. So simply just use the formula. This says that if two events are independent, then the intersection of A and B must be equal to the probability of A times the probability of B.
You do 0.4 times 0.25.
Just 2/5 there. And what do you get?
10%. Yeah, 0.
This would we would, because the question is expressed in percentage, then this, what's this talking about? What's this talking about? Let's say we have a Venn diagram like the last one. Let's say we have a Venn diagram like this one. Here on this one, we have the choice of geography and we have the choice of history. Are those independent events?
Yeah.
Should we try it?
No, because
No, literally, let's try it.
Okay.
So, in this Venn diagram, are the events independent? So, what is the probability of A times the probability of B? So, it's not 6. It's not 6 times 12. What is the, how many students choose geography?
6.
No,
There's 10 right, so
10. How many out of 26? How many choose history?
16.
16 out of 26. What does that give us as a fraction? 8 over 13. Can I have a decimal, 3 significant figures?
0.615.
0.615. What is the probability of A intersection B? All right, let me try it. Go. 10 over 26 times 16 over 26. Oh, I don't get this either. What did you get as your 3 significant figures?
0.237.
Good. Guys, try it again, get this number. What is the probability of A intersection B? Try to pay attention. What is the probability of A intersection B? 4 over 26. What is that as a decimal?
0.15%.
15.
15%.
0.1. 154. You must always give 3 significant figures, rounded correctly. Always give 3 significant figures. You'll lose the last point of every question if you don't. Every part question. So what does this imply? What does this imply? Always with a reasoning type question, we have to have an inequality. So 0.237 is bigger than 0.154. Put the numbers on the page balanced by an inequality. This is, we don't need an inequality, can we? Let's use the not equal symbol for this one. These are not equal. That implies the events are not independent. If these two numbers aren't the same, then the events are not independent. What does that mean? What can we infer from this? It means if you choose geography, you're less likely, it will impact on your ability to choose history as well. So notice that the intersection is a much lower probability. We would have expected almost twice the amount of students, or close to 60% of the more students choosing both if these were independent events. And this would make sense in an IB context because it's not easy to choose two subjects in group 3. Some people can choose two subjects in group 3, but some want to change their group 6 option to be computer science or art or one of these other electives. So even though they might want to choose it, they can't choose both. So there is some other factor which makes these two not completely independent events. Independent events means that if you've chosen A, it's not going to impact your decision on whether you choose B or not. This might be something like if A is students who do history and B is students who play in the sports team. These shouldn't really impact each other. Maybe if it was math higher level students in the sports team, there'd be a lot less in the intersection.
Crazy.
So this test for independence is trying to see if these are independent events. And sometimes they're not. If you think about the IB context, not many students do two sciences. Some do. Not many students do two group 3 subjects. Some do. But the choice of the first one impacts your ability to make that second choice. That's this one. This is an important formula. A intersection B. Okay, let me just look through the other ones. Mutually exclusive events. Mutually exclusive. That means if you choose A, you can't choose B. If you choose B, you can't choose A. How would that look as a Venn diagram? Try and draw a Venn diagram to describe this event. Discuss with the person next to you if you need to. You need to get like 4 colors. And then they all need to be complementary pastels. And you choose, for every page, you choose to do one color on the next page. Just two colors and complementary. Then, and then cycle it through. So you occasionally do just one color. Most pages you have a set and that is set. And it's really good. Go through adding your accent. Oh, I had beautiful from university days. I've done some really nice little mathematics. So I really taken my time. When I was prepping, I was really hard all of teaching. It's beautiful. And I had it in my desk before. one of these books. I didn't get a regular book like that. I got an expensive one. You know, you get like a leather cover and it feels nice. Then at the start of 2020, I got put into lockdown for being, I had met someone COVID positive. 2 weeks later, while we were coming out of my isolation, they put the whole city into lockdown. And then we had to evacuate, move home. I never got to go back into my class. I wanted to be able to go down because the school was open, but my wife refused to allow me to go. I'm like, in Brazil. I'm like, I want to go to my club. All right. Where am I? Am I paused? No, I'm playing. All right. So mutually exclusive events. It means something like this. That's why the probability of A plus the probability of B is the union, because there's no intersection. In the IB context, what subject choices would this be?
Picking the
AA math and AI.
There. Math, the two math subjects. You can't
Is
have
that the only one?
there might be, well, obviously.
Okay, bio and bio.
Yeah.
and that's
That's an option. But also the two English subjects, lit and language.
Yeah.
Can't be both.
Does anyone take English?
They don't?
It was
No.
on the
Yeah, it's a combination.
That's usually the brightest.
It was on the
Language is easier. All right. What about, let's have a look at conditional probability.
Conditional?
Yeah, this one's difficult. So
maybe the only touch on is the last.
this one means, sorry, can we have focus? This means the probability of A given B. Look for the word given in a question. This is a giveaway. Sorry, Masha, here, can we focus? Look for the word given in a question. If something has already occurred, and then we're looking for the probability of something to then occur. So if something has already occurred, and then we're looking for the probability of something else to occur. So we're looking for the probability of A happening once we know that B has happened.
Yes.
Once we know that B has happened. So what you do for this one, it's easier on a Venn diagram. So if we want the probability of A given B, if B has occurred, it means that all of this is taken out of the universal set. If B has already occurred, all of this comes out. And we are after this section over the total of A. So we're after this section, which is the intersection of A and B, out of a total of just B. Because the grey area disappears for conditional probability. And you're re-looking at your Venn diagram, looking at this one circle, and you want the probability of that out of a total of all of this. Let's try some questions. Have a go at this past paper question now for yourselves. Give you 5 minutes, work together in pairs. Okay. So Rosewood has 120 students. The students can join Club F or Club M. For the student chosen at random from these 120, the probability that they chose, that they joined both clubs is a quarter. So if they join both clubs, which part of the Venn diagram is that?
The middle.
The intersection. So the number of students in A intersection B is going to be 120 times a quarter. Is that 30?
No, 33.
That's 30. How are you
Yeah,
getting 33?
it's 30.
So that's this bit, isn't it? A intersection B is 30. So the probability that they join the music club is a third. This is the number of elements in the music club, sorry, M. This is 120 times a third, which is going to be 40. We've got 20 that didn't join any. So we need to calculate how many students joined the sports club. How can we do that? Which formula can we use? Look at the formula sheet. Which formula? Combine. So the number of elements in in S union M is equal to the number of elements in S plus the number of elements in M minus the number of elements in S intersection M. Which ones of these do we have? We have the number of students in this one, which is 30. We have the number of students in this one, which is 30. Sorry, this one's 30. This one's 40. We don't have these two. Can we calculate one of those two? No, we're missing. We're missing two. Guys, can you put your phone away? All right. How do we calculate the union? How many are in the union? How many are not in the union? How many are there in total? How many are in the union? This is 120 minus 20. So we can now find how many are in this one. So this is 100. This is the probability of F, sorry. This is the number of elements in S. This is 40 minus 30 is 10. So how many are in S? 90. So if there are 90 in S, how many are there here? 60. How many are there in M intersection complement S? This is M intersection complement S. How many are in this space? 10. What does it add up to? Check that it's correct.
It is.
So B. We need one student who is chosen at random, one student from this who joined the sports club is chosen at random. Find the probability that they choose both. So this is the probability of M given S. This is the probability of M given S. We want the probability that they joined the music club given that they joined the sports club. So it says one student chosen at random who joined the sports club. That means S is given. We want them to also to join both clubs. That means they then join the music club. So this is the probability of M intersection S over the probability of S. When you for these probabilities, you're dividing by the total, and the total is the same in each case. So you don't actually need all of that. You can do the number of elements in M intersection S over the number of elements in S. These are the same. So M intersection S is 30, and S is 90. So this is 1/3. Last question, C. Determine whether the events S and M are independent. How do we do this?
We look at
Turn to your formula sheet. Which test? Get used to opening that formula sheet. So I've handed them out this morning.
The independent events.
Okay. So we need which two probabilities?
That sports club and the music.
Intersection or union? We need the probability of the intersection of these two. That would be what? 30 over 120. We need the probability of, what's the other one? No? Find the formula on the formula sheet that we're talking about. Independent events. So it's not, we need the probability of S times the probability of M. So the probability of S is, what's the probability of S?
60 over.
No, don't get caught out by thinking that that is S. It's a very, very common mistake. We need 90 over 120 times 40 over 120. Put these two into your calculator and get decimals. Put these two into your calculator and get decimals. What do we get as our decimals? And for the other one? What do we get for this one? We get the same thing. What does that tell us? So, always include an inequality or an equality or inequality. So these two are the same. This implies that S and M are independent. Not yet. Now, have a go at these questions. Make sure you